It's a homework assigned on Tuesday for today, worksheet number 3, questions number 1 to 7. I'm putting the answers up here right now. Don't take a look at the solutions. Okay, we'll go over the solutions if you have trouble with it. Just take a look at the answers. First 3 are up there right now. Question 1, 2, and 3. Number 3 got cut off. Looks like the answer to number 3 should have been 48.0 meters per second. Anybody for questions 1 to 3? Anybody for 1 to 3? Those are all okay? Okay, let's take a look at number 4 then. The answer should have been 1.74 to the north. Anyone for number 4? Yes? Absolutely, yeah. We'll do number 4 from scratch without the solution in front of us here, okay? This one says a 1,500 kilogram car traveling 100 kilometers per hour to the south. I'm going to circle that south right away because it's a negative. I'm also going to circle kilometers per hour because I like to circle non-standard units. I like to circle things that should be negative and so on. 1,200 kilogram car traveling north at 100 kilometers per hour. The heavier car continues to move south after the collision, but slows to 25 kilometers per hour. How fast is the lighter car moving after the collision? Let's make car number 1 the heavy car, and we'll make car number 2 the light car. Doesn't really matter. Okay, in the end, you could have done it the other way around. That would have been just fine. If that's the case, if car number 1 is the heavy car number 2 is the light car, then this is going to represent M1. Okay, this is going to represent M2. This 100 kilometers per hour will be V1 or V2? Which one is it? It's going to be V1. It's going to be V1 initial or final? Right, V1I. Okay, traveling north at 100 kilometers per hour, that's going to be V2 initial, right? The second car traveling to the north at 100 kilometers per hour. The heavier car, that's car number 1, slows to 25 meters per second. That's going to be V1 final. And remember, we got to make that negative. Okay? I'm going to write the word negative in there just because that word south is so far away from that number. Okay? I don't want to get mixed up down the road and miss the red circle that I already put in there. How fast is the lighter car moving after the collision? We're looking for V2 final, V2F. Now there's 2 cars before and there's 2 cars after, so there's going to be 2 terms both before and after. M1 V1I plus M2 V2I equals M1 V1F plus M2 V2F. We've got the masses here. Can I cancel out the masses, by the way? Can I cancel them out? No, because they're not the same. If they were the same cars, then I could. You get 1,500 kilograms for M1. V1I is 100. We got to convert that to meters per second, though, right? 100 divided by 3.6 is 27.7777 meters per second. Do you know that in conservation of momentum, it's one of the few times, though, that you actually don't have to convert, as long as you're consistent. If you're solving a momentum problem or an impulse problem, you've got to be in meters per second. If you're solving a conservation of momentum problem, you don't actually have to be in meters per second, as long as you're consistent. Does anybody want to tell me why? Why could I leave it in kilometers per hour here and still get the right answer? Yeah, if it's in every term, the units just cancel each other out, right? So kilometers per hour in every term cancel. Okay, I'm gonna convert it because I think it's a good habit to convert it. The vast majority of time, we do have to convert. So I don't want to go and start getting out of the habit of converting to meters per second. So I'm going to do that, even though I technically don't have to here. 27.7778 meters per second for V1I. M2 was 1,200 kilograms, and V2I it's also 27.7, I guess, 100 kilometers per hour. Okay, that's all equal to 1,500 kilograms times the final velocity of car number 1, 25 kilometers per hour, gives me negative 6.9444 meters per second. Negative because it's to the south. Plus 1,200 times V2F. So we're solving for V2F here. Let's pull out the calculator just to make sure that we can do this properly once we've got it set up here. Let's say 1,500 times negative 27.78. Let's press equals on that. let's add that to, let's use some brackets here, 1,200 times 27.7778. Okay, that gives me the left-hand side. Let's add to that now, brackets, 1,500 times 6.944. We're adding that because it's a negative on the right-hand side. Take it over to the left-hand side by adding it. Okay, 2,083. Now let's divide that by 1,200. I end up getting 1.74, which is the answer that I gave you. Okay, V2F, positive 1.74 meters per second. That means it's to the north. Is that okay, Max? Well, if you do the kilometers per hour, if you leave it in kilometers per hour, you'd get the right answer. But your answer wouldn't be 1.74 meters per second. It would be whatever that is in kilometers per hour, right? Somewhere around 7, probably. What did you get? 6.25? That could be right. 6.25? Okay. So you did it right then. You just got an answer in kilometers per hour as opposed to meters per second. Having said that, I'm still glad you asked me to go over it because you got it right, but you didn't know that you got it right, so there still wasn't 100% understanding on that, right? Yeah. Take a look at 5 and 6 here. Some answers to see if you need either of those gone over. Anybody for 5 or 6? Number 7's the big one. Number 7's the one I'm pretty sure that we're going to need to go over here. 5, yeah. This one, just in the interest of time, just looking at the clock here, this one I'm going to leave the solution up there and we'll just point out a couple of things as we go through it, okay? Number 7, I want to do it in its entirety, so I want to save a little bit of time for that here. 92 kilogram football player, which I've defined as object number 1, running at 6.5 to the north. 85 kilogram football player running to the south. I should have circled this in red to remind me of that. In the end, you can see when I wrote down my givens, I got it as negative, okay, but I could have easily forgotten that without circling it in red. Okay, the 92 kilogram football player, player number 1, moves at 2.0 after the collision. That's going to be V1F. We want to find the velocity of object number 2, person number 2 after the collision. We want to find V2F here. So V1I, positive 6.5, V2I, negative 6. V1F, 2, V2F, that's what we're looking for. 2 objects both before and after the collision takes place, so there's going to be 2 terms, both before and after the collision takes place. Okay, make sure you put your numbers in here. Don't forget the negative there. Okay, negative 6. Okay, the right-hand side, okay, looks like it does right there. Let's solve for this and get negative 1.13. Let's pull out the calculator again just to do this here. We're going to say 92 times 6.5. Okay, let's subtract from that, brackets, 85 times negative 6. Okay, that gives me my left-hand side now. I'm going to subtract from that 92 times 2. I'm going to subtract it because on the right-hand side this time it's added. Mistake there, guys?
Yeah, you subtract it to negative.
Oh, yeah, right. Yeah, you're right. You're right. So we're going to say 598 subtract 85 times 6 then, right? Because we've already accounted for the negative there. We don't want to account for it again because that makes it a positive. Okay, so the left-hand side should be 88, not 1108. Kind of a difference, right? A bit of a difference there. Let's subtract from that, the right-hand side, 92 times 2. You can see how easy it is to make a silly mistake, though, right? Even though I had everything written down right, I still made that silly mistake and would have gotten the wrong answer. Let's divide that now by 85. We end up getting negative 1.13 or 1.13 to the south. Is that okay? Number 7, I know we're going to have to do number 7 here, so I'm not even going to ask you. Number 7 says a person holding a 15 kilogram gun containing one 50-gram bullet is riding on a train. This, by the way, on a circle. Just like with velocity, you could actually use grams here because the units cancel out. But if you do, You got to be consistent, right? It's either kilograms or it's grams. My suggestion is kilograms. 75 kilometers per hour. I can leave that in kilometers per hour if I want, but I'll circle it just because it's habit. Man fires the gun and the bullet moves at the velocity of 350 to the east, 350 meters per second to the east. What's the velocity of the gun relative to the ground? This is a hard question. This is a hard question. And the reason it's such a hard question is because we've essentially got two frames of reference here. We've got the frame of reference of the train. You're on the train firing a gun, and you've got the frame of reference of the ground because the train is moving relative to the ground. You have to pick a frame of reference. Now, it doesn't matter which frame of reference you pick, but you have to know which one you're picking. So you're either going to do everything relative to the ground, or you're going to do everything relative to the train. I picked the train. Okay, I went relative to the train. So you could absolutely get the correct answer if you did it relative to the ground. But if you do that, your method is going to be different than mine here. It's going to look differently than mine. And that's okay. Okay, what do we got here? I'm going to just write down my givens separately here just so it's a little bit tidier here in this question because this is a little bit harder. M1 is 15 kilograms. I'm going to say the bullet M2 is going to be 0.050 kilograms. I'm going to say V1I is 0 meters per second. Why is it 0 meters per second? The gun's on the train. The train's moving at 75 kilometers per hour. Isn't the gun moving at 75, Liam? Because it was 50 grams, and we have to convert that to kilograms, right? Why is it 0? The train's moving at 75, the gun's on the train. The gun should be moving at 75 too, right, Brett? Good. I'm doing it relative to the train. So relative to the train, the gun isn't moving. Now, if I was doing this relative to the ground, then V1I would have been 75 kilometers per hour, right? Whatever the speed of the train was. V2F here is 350 meters per second. Okay, 350 meters per second. Make sense? Okay, that's the velocity of the gun and the bullet. The bullet, the velocity of the bullet relative to the train, okay, after the gun has been fired, V2F. We're looking for V1F. But be careful here. When you solve for V1F, that's the velocity of the gun relative to the train. That's not what we're looking for. Okay, we're looking for relative to the ground, but we'll deal with that later on. Okay, let's solve this one now. Relative to the train, PI is equal to PF. Of course, the initial momentum would be 0 because it's all at rest relative to the train. M1 V1F plus M2 V2F. We've got 15.0 times V1F. That's what we're looking for here. Plus M2 0.050 times V2F of 350. When we solve for V1F there, it works out to be negative 1.16667 meters per second. If this was a multiple choice question, which I'd be surprised because I think it's a little bit harder than you'd see, but if it was a multiple choice question, this would be an option. Okay, but it's wrong because we've just found the velocity relative to the train. Now, if we want to find it relative to the ground, what are we going to do? We want to find the velocity relative to the ground. What are we going to do? Okay, well, first of all, let's take the velocity of the train relative to the ground. It's 75 kilometers per hour, which works out to be 20.833 meters per second. We're going to either add that to it or subtract it. Is it going to be 20.8 plus 1.16 or 20.8 minus 1.16? Okay, my son and I, when we go to the mall, we're not big shoppers. We go to the mall. We like to kind of entertain ourselves sometimes at the mall. Sometimes what we do is go to the escalators and try running up the down escalator and down the up escalator until we get in trouble, okay, which sometimes we do. But then we just move on to the next one. In the end, when I'm running up an up escalator, let's say the escalator is moving at 3 meters per second up. Okay, if I'm running up at 2 meters per second, then my velocity relative to the escalator is 2 meters per second, right? But relative to the store that's over here, my velocity is 5 meters per second, right? If I run down the up escalator, then my velocity relative to the escalator is still 2. But my velocity relative to that store would be, just 1 second here, guys, let's finish this, okay? Have a seat, please.
101.
My velocity relative to the store is 1 meter per second. Now, how are we going to use that to determine whether we add or subtract this, okay? The train is moving which way? Train is moving to the east. The gun is moving to the west. Am I going to end up with a number that's bigger than 20.8 or a number that's smaller than 20.8? Smaller, right? It's the same as me running down the up escalator. I'm going to end up with a number that's smaller. So I'm going to say 20.8 minus 1.16 or plus negative 1.16. And that's going to equal 19.7 meters per second. How many people got that? Good for you. Okay, that's a tough question. Good for you if you got that.
It's like both benefits.